Welcome to Dynamics Part 4, Impulse. And as you can see on your screen, impulse J is equal to the force applied to the body times the amount of time it's applied. The units of force are just Newton seconds. Newtons for force, seconds for time. However, if we break this down, we remember that a Newton is a kilogram meter per second square times a second. These reduce and we get kilogram meters per second, which is the unit for momentum. All right, we're going to do a quick little example here. Your rocket engine has a thrust of, and thrust just means a force that it applies to the craft, 1.5 times 10 to the fourth newtons. If the engine burns, that just means we turn the engine on and let it run for 20 seconds. What is the impulse? J is equal to F times T. The impulse is the force 1.5 times 10 to the 4 newtons times 20 seconds, giving us an impulse of 3.0 times 10 to the 5th Newton seconds. Pretty straightforward, just plug and chug into the equation. Before we move on to example number 2, we want to remember that impulse is force times time, but force can be defined as delta P over T. If we substitute back into the impulse equation, we get that the impulse is F, or delta P, divided by T times T, and the impulse is nothing more than the change in momentum. And if you remember back to one of the earlier dynamics videos, we know that delta P, V2 minus V1, because we're going to assume that the mass remains constant during our problems. Example number 2. A 25 Newton force is applied to a 2 kilogram body moving at 3.0 meters per second for 7 seconds. What is the new velocity? Okay, we're going to use the fact that impulse is equal to the mass times V2 minus V1. Impulse is force times time. Force we are given as 25 newtons. The time as 7 seconds. The mass is 2.0 kilograms. V2 is what we want, that's our unknown, minus V1, initial velocity, 3.0 meters per second. Left-hand side is 175.0 Newton seconds. Right-hand side is 2.0 kg times V2 minus 6.0 kilogram meters per second. Now, if you remember back earlier, we said impulse has ultimately these basic units. So the left-hand side of this equation becomes 175.0 kilogram meters per second equals 2.0 kilograms V2 minus 6.0 kilogram meters per second. Adding 6 to each side, I get 181.0 kilogram meters per second equals 2.0 kilograms V2. I'm just going to flop these, switch these two left and right. So I get 2.0 kilograms V2 equals 181.0 kilogram meters per second. Dividing both sides by 2 kilograms, I get a V2 equal to 90.5 meters per second. Okay, the key here is to remember that Newton seconds is the same thing as a kilogram meter per second. Okay, I hope that helped. Please feel free to leave a comment. Let me know if this is clear, you want more examples, anything in here that was fuzzy, or even a suggestion how to improve this. Thanks.